Machine learning and deep learning technologies have catalyzed this development. Computing machineries and the intelligence. He thought for the first time, why can't machine think? Who is the actuator? Actuators are the components of the machines that converts the energy into motion, by which environment it is working on, and what all the actuators and the sensor it is provided with. Hello everyone, welcome to the very first session of Artificial Intelligence and its application for 6th semester B.Ca student according to the University of MYSURU. Myself, Indu J, Faculty of Computer Science Department, Vidhyaashram First Aid College, the Temple of Excellence, MYSURU. Today we are going to discuss our first unit in Artificial Intelligence and its application as an introduction, right? Okay. So what is artificial intelligence? As name itself indicates, providing the intelligence artificially. Let's replicate the artificial intelligence, right? To whom we are providing? To the machine. When we are dealing with the computers, we expect computer to be more intelligent. We cannot give each and every line of the code. It's a bit tedious job. We want computer to learn by itself, uses its own intelligence. Providing that intelligence is called as artificial intelligence, or you can put it in very simple sentence that artificial intelligence is a process of making machine think like a human. Isn't it simple? What it is? Artificial intelligence is a process of making a machine or the computer to think like human. That is nothing but artificial intelligence. Let's go into the formal definition of artificial intelligence. Artificial intelligence is a field which combines the computer science and robust data sets to enable the problem solving. What do you mean by robust data set? Computer, we are using the computer science to learn. From where? From a previous data. That is called as robust data. Everything, whatever information we have in the computer is considered as a data. So depending on the data, computer is learning. It's analyzing a data. It is called as a part of artificial intelligence, that basically called as data analysis. That is also a part of artificial intelligence. You can assume artificial intelligence is a large umbrella under which many fields falls. What are the many fields that falls under the artificial intelligence? Is machine learning, making machine to learn by itself. How? By using a data science. Data science means analyzing a data for particular problem solving, that is called as data science. Data analytics, big data. Why big data? We cannot solve the problem with help of small set of data. We have to look all the probabilities of data. So we need large amount of the data. So big data is come into picture. So these are all some of the branches of artificial intelligence, what we can say. It also encompasses a subfield of machine learning and deep learning, which are frequently mentioned in the conjunction with the artificial intelligence. Okay, it is a combination of what? Machine learning and deep learning. What is deep? Learning a data, learning one particular set of data into its deepest form, that is called as deep learning. Okay, the foundation of artificial intelligence we have categorized into 4 foundations. First, thinking like human. We should make a machine think like human. We should make a machine think rationally. We should make a machine, once we have think like a human, it should act like a human. Then it should act like a rationally. What is rationally? Rationally depends on some particular logic which should be there. Without logic, it does not work. That is called as rational. So let's see each one of them. What is thinking humanly? Thinking humanly is a conjunctive science. So for example, what we can say, if you think like I should bunk the class today, that is thinking. What all the action you take to bunk the class today? What happens if I bunk the class today? I'll miss so and so and so on topics. I'll miss attendance. My attendance will go low. Then what should I answer to the teacher? What should I give the reason to the parents? These are all the actions that comes when you think something humanly, right? So that is thinking humanly. In 1960 conjunctive revolution, information processing psychology replaced previously orthodoxity of behavior. What is orthodox behavior? Doing it monotonously, always doing the same is called as orthodox behavior. If you want to do out of that orthodox behavior something different, then you should think what the result of this would be, what the impact of this behavior would be. So that is connectivity science, how it will be connected. It requires the scientific theories in the internal activities of the brain. So you should give some exercise to the brain, what may happen or may not happen, what if this happen, what the action should be taken, what if it does not work out, what is another plan B for me. So these are thinking capacity, making machine think like human, right? So what level of abstraction, that is what level of knowledge I want to have on that particular problem to solve according to the human intelligence. Then how to validate the request, whether this outcome is proper or not, how to validate that all comes under the thinking humanly. Predicting the testing behavior of the human subjects means what would be the outcome, if this is outcome, whether this outcome is proper or not, that is predicting. Then direct identification of the neurological data, that human brain is consists of many neurons, so they have developed one more algorithm called neural networks. So how the neuron is connected, very tedious thing, it's to understand how the neurons are connected. Similarly, they are trying to build a artificial neural network for the computer to think like a human. Then what we have is thinking rationally. What is thinking rationally? Having thinking with some logic, this if 1 plus 2 is a input, 3 is a output, because why? It is a plus operator what we are using, that is nothing but thinking rationally. Normative rather than the descriptive, we are thinking normally rather than descriptive, going in detail, we are thinking in logic. Then several Greek schools developed the various forms of logics, notations and the rules to derive such thoughts, making the kids to think rationally, think positive, and think rationally means there should be a proper output, there should be a true or false, it should be always true, that falls under rational thinking. May or may not have proceeded to the idea of mechanism, just thinking. Implementation is other part, just thinking rationally they have implemented in some schools. Direct line through the mathematics and the philosophy of the modern AI. How we are making to think rationally? With the help of mathematics, some theories, formulas, theorems, formulas, and that is related to the psychology of the modern artificial intelligence, modern intelligence tools. Using that, then once we have think humanly, once we have thought rationally, next what we have to act accordingly. So that is acting humanly. Once I think like I should slap the friend person, he is behaving very bad with me, so do you slap on the spot? No. Then you think what would be the outcome of this, if I slap him, whether he'll slap me back, or whether he'll scold me back, or he'll simply go away. These are all the rational thinking. And acting humanly means instantly you're acting on that particular action what you have thought for. A rational behavior, doing the right things. We have to do the right things on that particular scenario, right? You have to observe the scenario, what may happen or may not happen, depending on that your action should be. That is the right thing, that which is expected to maximize the goal of achievement given available information. With the present information whatever you have, with that, well, how efficiently I can reach to the goal, that action you should take. Does not necessarily involve thinking. This does not necessarily involve thinking, just acting upon the moment or the acting upon the scenario, what exactly is there. Then behind the programs, autonomy, perceptions, persistences and adaptiveness is also helpful to reach the goal. This is about acting humanly. Then acting rationally means this purely depends on the Turing test. Acting rationally depends on Turing test. What Turing test we'll discuss. Who developed the Turing test? Alan Turing. A scientist, a mathematician called Alan Turing, he's developed the Turing test in the year 1950. Computing machineries and the intelligence. He thought for the first time, why can't machine think? Okay. Then, can machine think? Can machine behave intelligently? This is the question that comes into his mind to develop this Turing test. Optional test for intelligence behavior. This is mostly considered optimal test to check the machine behavior. Let us see what is Turing test. What is Turing test? Here we have one machine. We have two inlay person. We have a layman. We have a layman. This layman acts as a tester. This layman acts as a tester. This layman asks the one question to the machine, and the same question is asked to the human being. Now, he is the person who is going to decide the reply which came from both A and B, whether it is a machine or it is a human being. It's a very simple test. So, one person is there. This person has to decide the answer for his question is from machine or from the human. If this person cannot recognize the answer is from machine or from the human, then machine clears the Turing test. So, a machine making fool of this person by giving the proper answer using its intelligence. Okay, that is what the Turing test is. One question is asked for the machine, one question is asked for the person. Both will replying back to the same person. This person C cannot identify this machine C cannot identify which answer is from the machine and which answer is from the human being. That is called as Turing test. This is used to implement acting rationally. Okay, rational acting will be implemented using the Turing test. Next, what we have is history of AI. What is a history, when it is started, how it is developed so far, that all we'll discuss in the history of AI. 1943 to 1955, that is called as a gestation period of AI. Gestation means budding period of AI. Someone thought, why can't machine understand what I am trying to say? So if machine could have understand by itself, it would be better. Like that, this is a budding test. Someone started to think, why can't machine think like a human being? In the 1943 to 1955 gestation. Then 1956, because of in 1950 we have started Turing test. Alan Turing is given some formulas to do the Turing test. We started birth of AI. In 1956 is the birth of AI. After 56, during 52 to 69, a great expectation was there that this artificial intelligence is going to change the world. That is the expectation what they have expected with the AI. Right. In 1966 to the duration 1973, it comes into the reality. These whatever the ideas developed, having the greatest expression, they started implementing that ideas, that it comes to the reality. 1969 to 79, knowledge is power. They developed one expert system. What is an expert system? Expert system is a knowledge based system. Everything for particular one area. For example, if I say it's a cricket, all the knowledge of the cricket will be stored in some system, that is called as expert system or the knowledge system. They have developed such expert system in 1979, in the middle of 69 to 79 for particular areas, right? Then 1980. From 1980, AI started its own industry. AI became its own industry with the help of expert systems. Then 1986, It's written of neural network. They have developed one network called neural network, which is very similar to the human brain network. Okay, they have developed one neural network. In 1987, AI become a science. Why it has become a science? What all extra we can explore, what the new thing we can add into, what all the new things we can develop using the AI. That is nothing but science. It became a science. Then in 1995, they started with the intelligent agents. Then what is the agent? We'll discuss in the further classes what is agent. Then history of AI, continuing with the history of the AI. Many, not only computer science, many other disciplines also has contributed to the artificial intelligence. Like they have given their viewpoints and then the techniques to the AI, like mathematics, commerce, everything has done their own contribution. The history of AI as a cycle of success. It has very good success, misplaced optimism. It has underwent very bad days also, that saying that AI doesn't going to work. Okay, so many ups and downs it has gone through with. In 1987, rapid increase in the technical depth. Technical depth has increased with respect to the AI in 1987 by building the existing thesis, base claims and the theorems. Rather than the theorems, they started doing the experiment on the particular theorems. Then real world application, they started implementing the real world application more than the toy examples, more than the simulation, we can say. Replication of experts with the data and the core repositions, collected more data and the repository for the expert system, and less isolations. In 1995, whole agents rather than the fragments. Instead of dividing the complete problem into sub-problems and solving the sub-problem, they created a whole complete problem solution at once. So whole agents, they have created complete agents rather than the fragments. Situated movements, internet environment, they have started internet environment in 1995 onwards, like whatever the chat bots you have, any bots, so that will be developed with the help of artificial intelligence. This is all about the history of artificial intelligence. Next, what we have is present, future and the past of artificial intelligence. As we have discussed so far the history of artificial intelligence, that all falls under the past of the artificial intelligence. Present, what we are working is on the concept of big data, data analysis, deep learning and machine learning. These are all currently what we are doing, working on with the artificial intelligence. Why we are using AI began to solve the problem with the seemed unbelievable before. Anyone thought of driving a car without a driver, right? So that is unbelievable in 2 decades ago. Now it is possible. That is into the reality now. So using these all things, we are able to solve such type of problems. Machine learning and deep learning technologies have a catalyzed this development. So who helped to catalyze this kind of the thoughts? These machine learning and deep learning technologies has catalyzed this type of thinking more. In the future, what we are supposed to do, prospects and the challenges we have to face using the artificial intelligence, making it self-learning. No human intervention is required, making machine to learn itself depending on the environment, and global AI network to develop complete whole world global AI network only. And then we have to have some ethics and the safety regulations whenever we are going with the global AI networks. Some rules should be followed, that has to be imbibed into the future. So this is the past, present and the future of artificial intelligence. Now coming into the agent. What is an agent? Agent senses the environment through the sensor and act on their environment through the actuators. We'll discuss what is actuators and what is sensor. So who is the agent? Agent is a person you can take as an example, or you can assume agent is a person who takes the surrounding environment to analyze each and everything and respond back to the environment. He is a agent. An AI agent can have a mental property such as knowledge, belief, intention. Okay, he should have a knowledge to understand what is happening around. He should have a belief that he can contribute something to the environment, and he should have an intention to do so. Okay, then an agent can be a human agent, robotic agent, and a software agent. Who are the human agents? Human agents can be ear, eyes, and other sensible organs. Sensitive organs of the human body is considered as a agent. For example, if you are moving in the road, yes, moving in the road, some accident happened. What you observe when policeman come? What all the details you give to the policeman? So this is thing happened. He came first, or the other fellow came first. Whose mistake was that? That you should observe, right? So how you are going to observe? By your eyes, by hearing, by sensing, by feeling, right? So these are all the human agents we can consider. When it comes to the robotic agents, what can act as a robotic agent? All the sense organs of the human body, like that we have a cameras. Like eyes, we have a cameras, infrared range finders, natural language processing sensors, and the various motors and actuators acts as an robotic agents when it comes to the machines. Then software agents are the keystrokes, file contents, and then the sensory input. By keystroke, when you dealing with the cyber security, if attacker is attacking to the system, how many times he has tried to attack and how many times he has cracked into your system, that all can be noticed by the key footprints, how it can be done. So those type of the inputs are considered as software agents. Okay, let us discuss more on the agent. What is agent? He is the agent, right? Agent senses the environment, whatever the environment is, so that will be sensed using the help of sensors. So he'll after sensing, what he'll do, he percept what is going to happen, what all can happen, what happened, right? He percept the environment, right? After percepting the environment, he has to respond back to the environment. With the help of what he is going to do the action? With the help of hands and legs he is going to do the action. So those hands and legs with the help of which is going to do the action, such is called as efforters. Is putting efforts to do the actions, right? So this is the agent and environment. Agent senses the environment. Once it senses the environment, he perceives the environment, what happening there in the environments. When he perceive, understand the environment, his respond, his act back to the environment with the help of efforters. Let us see what is sensors, actuators, and efforters. What is sensors? Sensors is a device which detects the change in the environment and sends the information to other electronic device. We are talking with respect to computers and devices, so which senses the change in the environment and give the information back to the environment using back to the agent using the electronic devices. So who is the actuator? Actuators are the components of the machines that converts the energy into motion. The actuators are only responsible for moving and controlling the system. Who is going to give the action back to the environment? Actuator. They are only the person who have a control to move anything, right? So can be electronic motors, gears, rails, etc. What is the example for actuators? Example of actuators are electronic motors, gears, rails, and etc. Then comes to efforters. Who are all the efforters? Efforters are the devices which affects the environment, right? How you are going to do the action? With the help of effectors. Effectors can be a leg, wheels, arms, finger, wings, fin, and display screen. These are all the efforters. Okay. Next, we are done with the agent. Now coming into intelligent agent. Who is considered to be an intelligent agent? And an intelligent agent, he is an autonomous entity which acts upon the environment using the sensors and the actuators to achieve the goal. With the help of sensors and actuators, he is trying to achieve the goal by himself. He is called as intelligent agent. Intelligent agent may learn from the environment to achieve the goal. He studies the environment, take up the important point, learn from the environment and he is achieving the goal. So, to be an intelligent agent, there are 4 rules to be followed. First rule, an AI agent must have an ability to perceive the environment. First, you have to observe the environment, perceive, understand the environment, what happening exactly. Then observation must be used to make a decision. Whatever he's observed, whatever he persisted, that is implemented, do the decision whether I should do it or I should not do it. I should interfere in someone matter, I should not interfere in someone. That is called as decision. The decision should be result in a action. Once I have taken with the decision, that decision has to be implemented in terms of action. You have to do that decision. Then the action taken by the AI agent must be rational action. What you mean by rational action? It should be in a proper action with some logic. So these are all the 4 rules when we can say the agent to be an intelligent agent, he should follow these 4 rules. So next, characteristics of agent. What all the characteristic agent should possess? He should have a ability to sense. Agent should have a ability to sense, percept the environment, and he should have a goal to perform. When he can sense and when he can percept, whenever he has a goal to achieve, then he should have a prior knowledge. Agent should have a prior knowledge about some of the data or some of the environment. If this happen, this what may be the outcome of this. If this has happened previously, what was the outcome of it? That is a prior knowledge he should have. And he should have very important thing, observation. He should have to observe the environment surrounded by agent. So once he can observe, he can percept. Then he should use his past experience to solve the problem or to achieve the goal. Past experience, from where he has got the experience, that has to be implemented to the current situation also. So then only he can reach the goal, right? So this is environment. With respect to the environment, all these properties agent should possess. Once according to all these properties, agent will take a decision. Depending on that decision, he is going to do his actions. So these are the characteristic of an agent should have. Then specification of task environment. What do you mean by specification of task? We can specify the task environment as P's. P's stands for performance measurement, environment, accurator, and sensors. How we are going to specify the environment? By its performance, by which environment it is working on, and what all the actuators and the sensor it is provided with. So performance measurement is a unit defines the success of the agent. Performance varies with the agent based on their different perception. How is going to perceive depend on that, the performance measure varies. Then comes with the environment. What is environment? Environment is surrounded by an agent. At every instant, at particular instant, what is surrounded by the agent, that is called as environment. It keeps changing with the time if the agent is set to the motion. If it is agent is set to the motion, environment is not constant, it is a dynamic, it's keep changing. Then all of you know what is accurator. Accurators are the part of the agent that delivers the output, that gives the action back to the environment. Then sensors, already we got to know what is sensors, which helps to sense the environment, the devices that helps to sense the environment. Sensors are the respective part of an agent that takes the input from the agents. Sensing the environment, take it as an input, that is called as sensors. Then agent environment. What is agent environment? Agent itself is not an environment. Agent is surrounded by the environment. Environment is not a part of the agent. Agent is a part of environment. Environment surrounded by the agent, but it is not a part of the agent itself. Environment can be described as a situation in which the agent is present. Okay, the environment is where the agent lives, operates, provides the agents with something to sense and act upon it. What is environment? This is important. Environment is where the agent lives, operates, and provides the agents with something to sense and respond back on it. So for example, what we have says peace, how we are going to give the peace for any environment is any agent. Consider the example, real life example, that is hospital management. Once we have a hospital management, we have to analyze the performance measurement, what is the environment, who are the actuators and who are the sensors for that particular agent. Who is the agent? Agent is a hospital management system. So, what is the performance we are expecting from hospital management system? To maintain the patient's database. Using that, patient health will be improved, and patient admission process, how to admit into the hospital, that is taken care by whom? Taken care by hospital management system, and the payment process is also taken care by the hospital management system. So, what is the performance measure I have? So, these are all the performance measure. Patient health, admission process, and then the payment. So for this performance measure, this agent should work on which environment? There should be one hospital, there should be a doctor, and there should be a patient. This is what the environment we had, right, for hospital management system. Then once we have a performance measure, we have an environment, we have an agent, with what all should be the actuators, what all the action to be taken. The prescription, doctor has to give the prescription to the patient, he has to diagnose what is going through with, and he has to have the reports, what all the reports he has to get. So these all act as an actuators. Then which all acts as an sensors. So symptoms, what is the symptoms patient is having, that has to be sensed by the doctors, and he has to respond back to that particular symptoms. So this is a sensors what a agent can have. Clear? Then agent environment, we have a different types of environment. So we have 7 types of environment here. We'll discuss each of the environment one by one. One is fully observed, partially observed, single, multiple, deterministic, non-deterministic, episode and non-episodic, static and dynamic, discrete and continuous, known and unknown. These are all different types of environment what the agent can work on. Let's see one by one. What is fully observed and partially observed? So in fully observed environment, agent has access to know what is going on completely. Complete access to the environment, that is called as fully observed. If we don't have a complete access to the environment, that is called as partial. So here, if an agent sensor can sense or access the complete state of environment each point of the time, it is called fully observed environment, or else it is partially environment. Example for fully observed environment is a chess game. What is the example? Chessboard is displayed for both the players has access to that particular environment. So it is a example for fully observed. And for the partially observed, we have a card, playing a card. So here only one player has a full access to his card, and another player having the access to his card. The first player cannot have access to the other player's card. So that is called as partially observed. Example for partially observed. Then what we have is deterministic versus stochastic. What do you mean by deterministic? If the agent's current state and selected action can completely determine the next state of environment. So what I am doing right now, that will impact on what someone is doing to the next, that is called as deterministic. This particular action determines the next action, that is called as deterministic environment. Example for deterministic environment is tic-tac game. You know, right? Tic-tac-toe game. So we can call it as XOO game also, right? So what if I do the X here, now other person move will depend on what I am doing right now, right? So determine this action determines the other person's action. So that is called as deterministic environment. The stochastic environment is a random in nature and cannot be determined completely by the agent. So example is Ludo game. So sometime it affects, sometime it does not affect. So it is called as stochastic. some part of the environment is affected by the by the present move what we have taken, some part will not be done, right? Then episodic and sequential. Episodic means complete thing will be done in continuous way and stopped. Okay, if I want to move some table from here to there, what have to, I cannot move for one phase and I have to keep, I should move the table from 4th floor to the 1st floor. How we can do? I can take it continuously down from 4th floor to 1st floor continuously, or I can stop in the 2nd floor, I can stop in the 3rd floor, like that also I can do. That is continuous versus sequential. What I am doing, stopping in between is called as sequential. Taking together from 4th to 1st is episodic, right? That is what an episodic environment, there is a series of one shot action, only one shot job is finished, and only the current prospect is required to do the action. What I am currently now, that is required to do the action, that is called as episodic. When it comes to the sequential environment, an agent requires a memory of past action to determine the next best action. Example is again chess game. What we have done, I have moved one pawn. If I have moved this pawn, what the other fellow has done, which pawn other fellow is moved. So he needs the past history to do the next move. That is called as sequential environment. Single agent versus multiple agent. A single agent having a hold on complete environment is called a single agent. More than one agent having a hold on complete environment is called as multiple agent. Here the best example what they can give is for the single agent is maze game. If you want one center into the maze game, only one individual will go and one individual come back, right? And multiple agents, what we have is team players. That is a football is an example for multiple agent. There are different agents who have an impact on that particular environment or that particular field, right? So that is called as multi-agents. Next what we have is another type of environment is static versus dynamic. Already you know what is static, which is constant. Environment is not changing itself, and dynamic means environment is changing itself. Static environment example we can say, if the environment can change itself while the agent is deliberating, that is called as dynamic. When environment changes itself, it is called as dynamic. Then the static environment, the agent does not need to continuously look at the world while describing the action, right? So it is already known by the agent, so he know what action can happen. When it comes to the dynamic, he don't know, because the environment is keep on changing, so he has to observe each and everything when the environment changes. So example is taxi driving. When we are driving the taxi, we don't know whether the environment is changed, whether there is a traffic, there is a rain, there is a free road, we don't know, right? So that is called as dynamic environment. And solving the crossword puzzle is an example for static environment, because the grids are static. Like this is a crossword, like this you will be having. The number of grids are static. You cannot change. We have to fill within this grids only. That is constant. That's why it is called as static environment. While traveling in the car or motorbike is an example for dynamic environment. Then discrete versus continuous. What is discrete environment? If in an environment there are a finite number of prospect and action that can be performed with it, such environment is called as discrete environment. We know it's a best example what I can give is algorithm. Look, algorithm is a finite number of sets, right? So that is a discrete environment. When it comes to the continuous environment, opposite to that, chess game comes under the discrete environment, and the finite number of moves that can be performed. A self-driving car an example for continuous environment. We don't have how much time we may reach to the destination, right? So that is a example for continuous. We have to keep on driving until unless we reach the destination. Example for continuous environment. Last type of environment we have is known versus unknown. Known means it should be known by the agent. The environment is unknown by the agent. where in the known environment the monitoring is less, in the unknown environment the monitoring is more. In the agent state is knowledge to perform the action, whether the agent has a knowledge of that particular environment or not. If the known environment, the results of all the actions are known to the agent, because he is there in that particular environment from many days, he know each and everything. For example, your classroom, you know where is AC, where is fan, where is desk, where teacher stands, where is board. This is a known environment for you, right? So he know the what all the action is going to perform on the known environment, and it is quite possible that the known environment to be partially observed and unknown environment to be fully observed. As the agent knows the environment, if it partially observed, he can get all the data, but for the unknown environment, he should observe each and every data, because agent has no knowledge on that particular environment. This is all about different types of environment what we have. Next, accessible versus inaccessible environment. If the agent can obtain a complete and accurate information about the state of environment, such environment is called as accessible. That is, he has access to the complete environment, then it is accessible. Inaccessible and else it is called as, if he don't have access to each and every movement, each and every action happening over the environment, that is called as inaccessible. Example, a room environment is accessible by the agent, but whatever happening all around the world, he does not have a idea, right? So that is an example for unknown environment. Information about the event on the earth, information about event on the what all the event happening on the earth. If I want to say the what all are event happening on the Mysore, you can be able, you will be having the knowledge at least. But if you ask what all the events happening on the around the earth, it's quite difficult to have information, right? So that is unknown, inaccessible environment for you, right? And then state of art is nothing but where all we are implementing this artificial intelligence, autonomous planning and scheduling. We are implementing the artificial intelligence, game playing. Many of the system, you need not to have two players. One player is you and another player is your system. System will play along with you, right? So game playing, that is artificial intelligence implementation. Autonomous control over the particular applications and diagnosis in the medical field. Rapidly we are using the artificial intelligence for analyzing the reports that will help the patient as well as for the doctors. Then logistic planning, nowadays whatever you are using e-commerce site, all comes under the logistic planning. And robotics, many of the time nowadays we are using, not you going with the open heart surgery, we are going with the endogram and angioplasties, like that will be done with the help of robotics. Small robot will send into your parts of the body, and they'll remove the blocks of arteries. So that is what the robotic, they are using the artificial intelligence for the surgeon. Language understanding and the generation, so translating from one language to other language, converting the speech to the text or text to the speech, like that. So language conversion. The problem solving, most of the time whenever we are using the artificial intelligence, is to solve the real life problem with the help of machine or with the help of computers. This is all about introduction for the artificial intelligence. Thank you.